Welcome to the Calculus A section. In this section we will be discussing implicit differentiation. Now, up until this point we have been deriving functions with respect to x. Now it's important to understand what this means. When we write out the derivative notation we state y prime and f prime of x. So let's use y equals x. When we say y equals x and we take the derivative, we say y prime is equal to 1. But what we're truly doing is saying that the derivative of y with respect to the derivative of x is equal to 1. Now, it's important to note what we just said there. The derivative of x is equal to 1. The reason why y prime is converted to dy dx and x is not is because we are taking the rate of change of the function x, which we will draw on the right side. Oops, that is not an accurate drawing. We are saying that the derivative of the function f of x is equal to x, or y prime of x is equal to x, is changing at a rate of 1. So at x equals 1, we know that it's going to be y is equal to 1. We know that at x is equal to 2, y is going to equal 2. We know that x at 10, y is going to equal 10. So that means our derivative is changing at a rate of 1 with respect to x. Now, if we were to say that we wanted to take the derivative of, say, f of x is equal to xy, this is a little bit difficult. Now, using the rules that we know, we have to try to differentiate this. So f prime of x is equal to, and since we have two variables multiplied by each other, we're going to use the product rule, so we'll say x prime of y plus y prime of x. So we know how to compute the left side of the derivative of the function. We know that the derivative with respect to x is equal to 1, so it's just 1 times y plus, but now we have this y prime. So what we do here is we convert it to dy dx. So we just have dy dx times x. And that is what we have on the right hand side of this. So we have y is plus dy dx times x is equal to f prime of x. So now this is called implicit differentiation. We are accounting for the rate of change of another variable with respect to x. So let's try a problem. Let's say we wanted to find the derivative of the function f of x is equal to 2x squared plus 2y squared, and this f of x value we're saying is going to equal 32. So we'll say 32 equals 2x squared plus 2y squared. Okay? So when we take the derivative, we're going to get 0, because the derivative of any constant is going to be 0, is equal to 4x plus 4y times dy dx. And we generally like to isolate our dy dx, so what we're going to do is we're going to subtract our 4x to the other side, and we are going to divide our 4y over. So we're going to get negative 4x equals 4y dy dx, and that is going to leave us with negative x over y is equal to dy dx. And later when we take the second derivative, or the second implicit differentiation, so say we wanted to make this function f double prime of x, we would plug back this dy dx into the function, and we would substitute in our variables negative x of y, but that's looking a little bit down into the road. But I hope this lesson helps, and if you need more assistance or would like to do more problems, the website has a bunch of examples. Thank you.